Hi guys, how are you? Tell me about how are you? What's up? What are you doing? What is your day? And what is happening in your life? Anything at all, whatever you want to share me. So this is the last topic of this chapter, probability in the discrete mathematics. 7.8 Chebyshev'S inequality and law of large number. So let's talk about the introduction. The standard deviation, we already talked about the standard deviation in our previous lecture of, and standard deviation of a random variable x. Random variable, you already know what is the random variable. Measure the weighted spared of the value of x about the mean. You already know about the mean. If you read the some different book like NP Wali, so here the NP Wali sir use the x bar sign for the mean. Okay, so what is the formula of mean? Summation of x divided by n. What is the summation? The given value in our problem, then just a sum of all of them and divided by n. What is the n? Number of x. Thus for smaller standard deviation, we would accept that x will be closer to, what is the mu? What is the mu? Mu is mean, not say is mu. Okay, x will be closer to mu. A more precious statement of expectation is given by following an equality named after Russian mathematic PL. This thing is dependent by surname of surname of Russian mathematician. So this is just a introduction. Okay, don't worry. So just learn this theorem. Okay, let x be a random variable with mu and standard deviation. Then for any positive number k, the probability that a value of x lies in the interval mu minus k mu. What is the k value is given our problem. Just first you need to minus, and then second one you need to plus. So here you can find the interval. Here the axis lies between those in this two interval is least 1 minus 1 upon k square. That is probability of mu minus k variance less than equal to x, and x is less than equal to mu plus k1, and whole thing is greater than 1 minus 1 upon k. So this is the thing. This is thing you need to remember. Suppose okay, let's consider the problem here. Suppose x is a random variable with mean. This mean is given. Okay, standard deviation also given. What the conclusion about x can be drawn by Chebyshev's inequality for k. K is also given, I already tell you, and here we find the k. K again given this. So how can you do this? Just put in this formula. Don't worry. I'm here for crack your all the doubt regarding your knowledge. Mu minus k. Mu, what is the value of 75? 75 minus, what is the value of k? Here we find the first 2. What is the value of his 5? Just put it. Answer is 65. Again plus 85. So first x lies between 65 and 85. This is the interval. This both thing. This 85. This is the interval. Okay, of x lies between them. So just put value of k, and what you can find this, and just put the k and find value 3 upon 4. So how can you find this? X lies between 65 and 85, at least 1 minus 1 upon 2. Square this 3 upon 4. So what your answer? This is your answer. Okay, this is your answer. And again you need to put the k value similarly and do this, and you find the value of k here and you find 8 upon 9. So sample mean and law of large number. This is the last and another part of this lecture series. Sample mean and law of large number. What is this? Consider a finite number of random variable, finite number x, y, z, and sample space S. They are said to be independent. You already know what is independent for any value given x, I, y, z, z, k. So probability of x random variable equivalence to this. This is equivalence to this. So okay, so don't be confused, don't be afraid. Just observe this thing. Okay, this is not the necessary for an exam, but you need to understand this. What is this? But this is the sample mean, called sample mean. This is the most important thing. Okay, so I equal to 1 to n, then 1 to n xn divided by n. So what is the n? What is the n? Just sum of all these value, random value which is given in your problem. So this is the formula, just, and this is the approach to crack your problem of law of large number. So this is the problem, and no, this is the theorem. Okay, this is the most important theorem. For any positive number alpha, positive number, not a negative, no matter how small. Okay, it may be possible, it can be a fractional value alpha. Okay, and this is the interval of how can you find the interval mu minus alpha, mu plus alpha. So approach 1 as an approach infinity. This is another formula, n implies infinity. So let's talk about the example. Suppose I 5 times tossed. Okay, so this is the value given in your problem, and just put in this formula 3 plus 4 plus 6 and divide by 5. Why 5? Because 5 times this is the end. Put 3.6, and what is the mu? 3.5. Okay, so the law of large number tells us the n gets larger, there is a greater likelihood x n bar will get closer to 3.5. Okay, thank you for watching. Do subscribe our channel. You can find us on the Google and on the GitHub, on the Facebook page, group, and Reddit, Pinterest, whatever you want. So thank you for watching. Thank you, and please share our video for your friend. Thank you.